Alright, so I will be working more or less with the same topology. So what I'm going to do is I'll keep the same firewall. It's connected here. We have a PC connected here, which is admin PC. We have R1 present here. We have R2 present here, followed by R3 present here. I'll take, isn't it? R2 and R3 are connected together, wherein this is VLAN 101, right? Firewall is there, wherein these are connected this way, right? Now what I'm going to basically do, this is the existing topology what we were working last time, right? For promiscuous, isn't it? We had IPS here, wherein one of the interface of IPS, which was G00, was used, isn't it? Correct. Another interface was management interface, which was going all the way from here to inside VLAN, wherein this was VLAN 100, VLAN 101, and here was VLAN 200. Now what I'm going to do is we want to deploy IPS in inline mode, right? So in inline mode, I'll put IPS right in the middle. This is IPS. Right? I'll use interface this will be interface, and this will be interface G0/. Fine. On firewall, it's still the same interface. This is R2's G00 interface. Same connections. Okay, I have not changed the existing devices. Only thing in between I am. This is your management 0/0. Okay, so if you look, this is how it is. We have a VLAN here, okay, and this interface of the IPS, which was already there, is also connected here. Okay.
Two IPS.
No. Wait, I'll tell you. This was VLAN 200. I have the same IPS box. Understand this. It's the same IPS box, but the same box has how many interfaces? 4, right? So I have used G0/0 for promiscuous mode, which is here. Now I am using 02 and 03. I am using these two interface for inline. One more interface is remaining, which is G0/1. I'll tell you when we'll use this. You guys get this? So I need to make some changes in between. What are the changes? Only extra part what is present here is this one. isn't it? Right? So what I need to do is I need to move this interface of IPS and this interface of the IPS in the right VLANs. Okay, how we are going to do this? Take a look. We have R2, where in R2's G0/0 is there. We have IPS, wherein this is IPS G0/2 and this is IPS G0/3, which in turn here is connected to firewall, isn't it? Okay, wherein this interface is E0/0, which is basically firewall outside. Right? Now you understand that this interface of router R2 has IP address of 110.1.20. Isn't it? And the IP address of firewall was 110.1.20.10. Isn't it? Last time around it was like this. R2 was there and firewall was there. They both were in VLAN 200, isn't it? Now this time around, between R2 and between firewall I am putting what? Here in between I am putting IPS. So what basically IPS is doing is, your same subnet, your subnet is what? 110.1. The same subnet now this time belongs to VLAN. So I need to divide the VLAN. So I'll keep this VLAN as VLAN. Let me change this one. I'll keep this VLAN as VLAN 200. And I'll change this VLAN to VLAN, let's say 201. Guys, get this? So this side VLAN 201 is on same subnet. VLAN 200 is also on the same subnet. But to communicate from this to this, you need to go through what? You need to go through IPS. To make it work on IPS, what I'm going to do is, on IPS I am going to form interface pair. I am going to pair up interface. So I'll give some logical name here. Let's say what should I give? I'll say int pair. I give this name and I pair up interfaces. The physical interfaces are which one? One is G0/2, another one is G0/3. So I am saying if anything is coming through 0/2, send it to 0/3, and if anything is coming through 0/3, send it to 0/, which means if anything is coming through G0/2, send it to 0/, and if anything is coming through 0/2, send it to 0/2 to 3 to I'm forming what? Interface pair. Okay, so basically what I'm doing is I'm going to form interface pair wherein I'll have two interfaces in the pair, and then I'll assign this interface pair to virtual sensor 0. Now virtual sensor 0 will check the packets against signature database 0. You guys get this? Get this or not? Both the interfaces are now one interface. The interface name is? Now this interface is applied or assigned to virtual sensor 0, which actually checks the packet against signature database 0. So last time around we had assigned G0/0, like we have assigned G0/0 here. We assign G0/0 to virtual sensor 0. Now this time we will form a pair, and the pair will be assigned to the get this. So first of all, let's make the required changes in the topology. So let's note down the required changes. Required changes are firewall E00, which is connected on switch 3 port number 13, which is already in VLAN 200, should be now in VLAN 201. Fine. Then this will remain in VLAN 200 only. That's okay. Apart from this, these two interfaces, this one and this one. Now this one I need to check 02 and 03. I think these are on switch 6. Let's check IPS. Yeah, switch 4 15 16, switch 4 15 and 16. So come here. So this is connected on port number 15, this is connected on port number 16. So this is on switch 4 port number 15, and this is on switch 4 port number 16. So this will go to VLAN 201, and this will go to VLAN 200. So we go and put each one in the right VLAN. So as of now, what we need to put, first of all, switch 3 port 13. That's firewall outside interface. So go to switch 3 port 13. My PC. Start. इसको क्या हो गया? सारी कीज we need to go to switch 3, right? Switch 3 port 13, right? Show running interface F0/13 13. See, it's already in VLAN 200. I'll change it. Interface F0/13 should go to switch. Should go to switch. Switch port host. Switch port access VLAN 201. Then anything else? This is okay. Then these both are on switch 4. So switch 4 port 15, 16, right? Go to switch 4, which is not here, which is here. Switch 4 config T. Do show running interface F1/0/15, 15 and 16, right? 15. So interface F1/0/15. This goes to VLAN 200, and interface F1/0/16. This goes to VLAN 200 and fine. That's perfect. So this segment will come and discuss later on. So as of now, this is not there. So your management is coming all the way from here, this way and this way. This is your management, M0/0. Fine. Done. So what do? We are going to form a pair. Which type of pair? Interface pair. So steps are, you go to IPS, this is not required, okay, I'm just removing it. Okay, so let me just disable this interface. Hang on for a minute. Interface 0/1. Okay, so interface is what we need. Are 0, 2 and 0, 3, which are down, right? So I go to configuration, I go to interfaces, and I enable 0, 2, which is here. I say enable, apply, and I enable 0, 3. I say enable and apply. So two interfaces, what I need are 0, 2 and 0, 3. I enable both of them. Good. Now right below interfaces you have interface. Yes. Click on it, say add, give some name, int pair, and here select the two interfaces 0, 2 and 0. Okay, inline interface pair. Say get this. So remember the name here, int underscore pair. Okay. The next thing, what do? We go to virtual sensor and apply this, assign this to the virtual sensor, right? So you go to policies, go to IPS policies right on the top, come to virtual sensor and click on edit. You see your interface. So any data received on these interface pair or on this interface pair, check it against signature. Say assign, say okay. Get this? Finally click on. Okay, your verification would be this. If things are proper, not here. If things are proper, you should be able to ping R2. I'll not apply it here as of now. Is this right? Just verify this. 15, 16, 200 and 201 and 200. So switch 4.
15 is on 200, sir.
15 is on 201.
No, 15 is on 200 and 16 is on 201.
Alright. The issue here is VLAN 201 does not exist. Fine, so what do I need to do is I need to go to server switch, which is switch 1, and I say enable config t VLAN 201 and right. This brings up VLAN 200 on switch 4 as well, and because of this, yeah, this is okay. So here G02 is connected, which is on VLAN 200, which means on R2 site, and 201 is F0/16 is in 201 VLAN, which is basically connected towards the firewall. So now if we try to go to firewall, this should fix the problem. Yep. So this is good enough of a test, right? So if you're able to ping, you're able to ping from where till where? You are able to ping from here all the way through IPS 2, which means this all are correct, and even your pairing is correct. So this is how you are going. You're going this way, you're going this way, this way, this way, and same way you're coming back. You're going this way, towards the pair, coming, leaving. Get this? Fine. So now we do the remaining thing. The next part is assigning the interface pair to the virtual sensor, which will check the packets against signature database, right? So let's go and do this. I assign interface pair and say OK and say apply. Tune signatures here. I tune the signature. So we already have this, right? ICMP echo request. Remember last time when we did this, what was happening? Some packets were able to reach your network, then the host was blocked, isn't it? Now the action would be immediate. So I change the action. I say deny attacker inline. Let's say I say produce the alert plus deny the attacker who is doing this. You click on OK. You click on apply. Fine. As of now, go to monitoring. These are the old ones. I'll say past 2 minutes. Nothing. Right? What do? We go outside R3, let's say, and from R3 we say please ping 110.120 dot, or let's say ping router 10.11.11. Not a single packet. Not a single packet makes it to your network. Go to IPS, say show me the event. You get the same signature, right? 2004. Check it. ICMP echo request coming. This is the signature ID. Fine. Coming from R3 towards R1. Fine. This is inline. How we have deployed this? Inline interface pair. This deployment is known as inline interface pair deployment. Fine. We have one more, okay, which is, so this part is clear, isn't it? Okay. Now let's extend the topic. So what I'm going to do is, you see I have one more interface remaining. Now I want you to understand, I used this interface for promiscuous mode deployment. I used this for inline interface pair deployment. I have one interface remaining, which is G0/1. I want to use this interface as well. One way of using this is, I can use this as what? I can use this in promiscuous mode, right?
Already promiscuous mode is used in GSM.
So you can use another one also. What's it? Okay, we have one more deployment, which is inline.
So between this promiscuous mode there will be interface pair.
We have inline VLAN pair. Now what is inline VLAN pair? Check this. Let's say I have router
Between these two promiscuous modes, sir.
Let's say I have router R4 here.
So you do this implementation only with one device.
Yeah, exactly.
Promiscuous mode with one
Exactly. Okay, so I have R4 here. I take one of the interface of firewall let's say this is E0/2. How many interface do I have of IPS? How many? One. What I'm going to do is I'm going to split the interface of IPS. So this is what I'm going to do basically. This is your IPS. The only interface available with you is as of now G0/1. You can't deploy it in inline mode, right? For inline you need two interface, but you have only one interface. So in this case what I'm going to do is I'm going to split the interface, wherein one interface is going to connect with R4 and another interface is going to connect to firewall E0/. You guys understand this? So basically this interface of the IPS I am going to divide it into two. Fine. So the interface of IPS, which is G0/1, this gets subdivided. This gets subdivided into two interfaces. Let's say
G is for inline VLAN pairing.
Yeah, G0/1.0 and another one, let's say G0/1.1 or 1.2, let's say. So on IPS I do this. I do splitting. I create sub interfaces. The same interface of IPS is connected on switch 5 port number 2 F1/0/2. On switch this interface I make as trunk. So you need to understand some piece of information, which is the interface on the IPS. What do? We create sub interfaces, right? And the interface, the cable which goes to layer 2, to the switch, that particular port of the switch is made as trunk. So this is on IPS and this is on switch. On switch make the same port as trunk. On IPS subdivide the interface.
You say trunk on which port? On the switch 5?
Yeah. See, this is how it is. So now this time around what I'm going to do is I'm going to take firewall. I'm going to take E0/2 interface of the firewall. This I'll make, let's say, DMZ. The network I'll keep, let's say, 172.16.30.0, wherein 30.10 is the IP address of firewall. Okay, in between I have IPS. So what I'll do is I'll create sub interface. This is IPS G0/1 interface. Well, let's draw out the physical one. Hang on, I'll draw out the physical one. This interface of firewall is connected on switch 6. Let's check the port. Wait a minute. So switch 6 port 6. Okay. So this is switch 6 port 6, right? We have trunk link between switch 6 and this is where your IPS is connected. This is your switch 5, and on switch 5 port 2 is connected your IPS. So this is your IPS port number G0/. Okay, another device is your R4. So from switch 6 we have a trunk wherein you go and connect to switch, not switch 4 exactly, it's switch 3. Hang on, R4 is the router, isn't it? So let's see where R4 is connected. R4 F00 is connected on switch 3 port 2. So go to switch 3 port 2. So switch 3, this is trunk. On switch 3 port 2 is connected R4. Guys, you get this? Actually, if you look, it is like this. See, actually, if you go, it's like this. Have firewall is there, where firewall E0/2 is there. In between, IPS is there, and here you have. Logically, this is how it is. Wherein this interface here is, let's say, G0/1.0, and this interface here is G0/1. Sub interface. Guys, get this? This is logical, this is physical. This interface here has the IP address as 172.16.30.4. So basically what we are planning to do is, we are going to put this interface of firewall into some VLAN. You guys understand this? Let's say we'll put this in VLAN 30. This interface of R4 will be in VLAN 31. I want you to understand, R4 is 172.16.30.4, where firewall is 172.16.30. Same subnet.
VLAN 30.
Yeah, but same subnet is on two different VLAN. That's what we are doing. Same subnet, but it's on two different VLANs. And how do we connect both of the VLAN? Through IPS. Right? So this interface of the IPS, which is here, 01, we make it what? We make it trunk. And we allow traffic of VLAN 30 and VLAN. So who is in VLAN 31? Exactly. Who is in VLAN 30? So we say any traffic that is coming from R4 can go to R30, and any traffic which is coming from firewall can go to. Get this? So actually the traffic is going to travel like this. Let's say packet will come from firewall outside, will come to firewall, will go to DMZ, will then, because it's in VLAN 30, it will go through the trunk, it will go to IPS VLAN 30 sub interface, which is this one, and then it will come out from VLAN 31 sub interface. Again it will come out from here, it will go back through this trunk, all the way it will reach. You guys get this?
So that means.
So this one is VLAN 31. Then it comes out all the way through trunk, it reaches R. So in blue you have VLAN 31, in red you have VLAN.
So that means here IPS is like a router.
Router on a stick, exactly.
Like a router. That means default gateway. You can
No, it's
apply
not,
the.
it's not on routing. Sensing interface of IPS does not have any IP address.
But in this case, it's
There's
like
no IP address. Where I'm using IP address? See, it's like this.
because it joined two VLANs.
Yeah, so it's like this. You have firewall, wherein firewall is 172.16.30.10. Through IPS, it's connected to R4, which is basically nothing but same subnet, 172.16.30.4. Same subnet. But this belongs to VLAN 30, this belongs to VLAN 31. Only a link which is can carry multiple VLAN traffic. That's the reason IPS G0/1 interface, I make it what? Trunk. And on IPS I subdivide interface. I create interface G0/1.0 and let's say G0/1.1, wherein one goes to VLAN 30, another one goes to VLAN. So the packet which is coming from R4 goes to VLAN 31. Through this it reaches VLAN 30 and reaches. Similarly, the packet which is coming from firewall VLAN 30 goes to IPS through interface through VLAN pair, goes to VLAN 31 and reaches. Get this? Right? So we configure this. So here is your configuration. So basically what you need to do is firewall E02, which is connected on switch 6 port 6. This goes to VLAN. Which VLAN? This port goes to VLAN. And R4, which is connected on switch 3 port 2, goes to VLAN. Exactly. And IPS port 01, which is connected on switch 5 port 2, becomes exactly. Right? So let's do one by one. Let's first go to switch 6 port 6. So go to switch 6, which is here. Switch 6, interface G1/0/6, switch port host, switch port access VLAN 30. Next, you go to switch 3 port 2, switch 3 port 2 VLAN 31, which is here. Switch 3, show running interface port 2, not configured, interface F0/2, switch port host, switch port access VLAN 31. Exit. Remaining is what? IPS. Go to switch 5, Which port? 2. Make it trunk and say switch port trunk. Allowed VLANs are 30 and
61.
This is the running config or port where IPS is connected. Perfect. Up till this point, we need to configure firewall and router R4. So I go to firewall. I configure interface E0/2, name if DMZ, security level of 50, IP address is 172.16.30, right? 30.10. And I go to R4. Yeah, it's F00. Interface F00 with an IP address 172.16.30.4. No shut. Exit. Your gateway is firewall. If everything is proper, we should be able to ping from R4 to firewall, right? The traffic should pass through IPS. That's the confirmation, isn't it? I have one doubt whether VLAN 31 does exist or not. So let me go to switch 3. Show VLAN. I doubt VLAN 31 is there. No, there is no VLAN 31. So I need to go to server switch and create VLAN 31. Show VLAN. One port should be in VLAN 31. Fine. All good. So this moment, if I go to R4, if I say ping 172.16.30.10, this should actually work. It's not working because go to IPS, go to IDM, go to home and check your interface 01, which we are using is basically actually what? Down, right? So what you need to do is first we go to configuration, we go to interface, and we enable G0/1 first of all, right? This is not enough. Second, you go to VLAN pairs, create a VLAN pair, click on add. Which interface we are using for interface VLAN pair? 0, 1. Sub interface number, let's say give 31. That's just a number. I'll show you how it's used. VLAN 30 and VLAN 30. Okay, say apply. At this moment should be functional, which means you have properly deployed it in inline in VLAN pair, because you are able to pass the trap. Fine. Exam, this is how this would be, right? Task is to form in deploy IPS with this kind of thing in inline VLAN pair. There's a firewall somewhere, so if this doesn't work out, your firewall configuration won't work out. Let's say they ask you to there is another task R4 which is on private network, when it's going out should get translated, so you have to do what? Translation, right? And try to telnet outside and check whether its IP is getting translated or not. How will you verify this? Until your traffic doesn't go to firewall, it won't get translated, right? And you lose the whole mark. Or let's say you have VPN through the firewall. The VPN has to terminate on R4, and in between you have IPS, that this deployment. Until this deployment is not proper.
Which you put the IPS where?
In between, man.
Between router and firewall.
Yeah, obviously. Where we have put now? Where is IPS now?
Inline, yes.
Then?
With VPN also.
Yeah. Well, how does it affect? Where is the next one? Not next one, this one. Yeah, here. We have put IPS here. They say the VPN should come from this router all the way this way and should terminate here. So until this segment is not proper, or maybe this segment is not proper, how this will work? Things are interdependent. So you lose mark not only for this, you lose mark for the VPN section also. You get this? Fine. So the tuning of the signature is still same. Okay, how you're going to tune the signature, all those things are still same. How you assign. Let's say, so we have created one VLAN pair with name this, isn't it? So what I want to show you is, if you go to CLI of IPS, and say this is your configuration. Remember this name?
Okay.
You remember this? VLAN pair, and this is get this? This is interface pair, where we have paired 02 and 03. See, both for both admin state is enabled. This is VLAN pair, wherein interface G0/1 is subdivided, wherein it's connecting VLAN 30 with VLAN. So any traffic coming from 30 goes to 31, goes out. Any coming from 30 all the way comes and goes out to 30. Get this?
It is same like interface page, but here we use VLAN.
So you can say config T the 31 was sub interface number. Fine. So the two interfaces are like this. Check. Go to policies, go to IPS policy. Okay. Now what I'm basically doing is, this is how it's functioning. I want to change a bit. You see this one here, the packets which are coming through this interface pair are going to which virtual sensor? 0. Who is checking these packets against signature database? I can create one more virtual sensor. So all the packets which are coming through interface VLAN pair, here I send them to, let's say, virtual sensor 1, which checks it against signature database 1. This is virtual. Okay, so how you add one more virtual sensor? You need to click on this, say virtual sensor 1, give description, virtual sensor 1 for DMZ zone. Okay, what I want you to check is, look at this, your sub interfaces. You see the sub interface, it's 1.31. Why 31? You remember when we were creating sub interface number, I had specified 31. That's why I took 31. But still it's combining what? Your VLAN 30 with VLAN 31. Fine. So don't worry on this number. Why it's 31? Usually we have seen it's G0/1.0 1.1. Why it's 1.31? How come it's 1.31? This can be 1.1 also, 21 also, 31 also, 51 also, 61 also, whatever you specify. Get this? So I assign this one. I assign this one to virtual sensor 1. I need signature database 0. No, I'll change this. I'll come back here later. Assign. So right now, this is the implementation. Apply. I want to create one more database for signatures. Okay, so how you add one more database? You go to signature and here you click on add, gives name signature db0. Just missing one. Let's see. Fine. 60 signature db0. That's mine. One more. So I'll tune all the signatures for normal traffic what is coming there from a edge router till the firewall through this one, and the traffic which is between the firewall and DMZ zone, that for them all the signature will be tuned under this. Get this? So this is done. So I added this one. So I want that whatever traffic is coming on inline interface pair, which is coming from 02 to 03, 03 to 02, that should be checked against, so this one, this traffic. This traffic between these interface should be checked against virtual sensor 02, should be binded with virtual sensor 02 signature database 0, which is there, right? packets on interface pair should be through virtual sensor 0 should be checked against signature database 0, and the packets which are here, which are on VLAN pair, those should be checked through virtual sensor 1 against signature database 1, which means sig database 0, sig db 0, the custom one what I created now. So how do I edit this? Click on this one, say edit. So whatever packets are on this VLAN pair, check it against sig. You get this? I want you guys to understand this. The packets which are coming from 02 or 03 with the help of virtual sensor 0, they are checked against signature database. So this is where, this is between R2 G0/2, you have IPS here, wherein you have G0/3 which goes and connects to. So the packet on this is checked against what? Checks against sig 0 with the help of virtual sensor 0. Whereas the packet which is between firewall and R4, this traffic is checked against with the help of virtual sensor 1 against signature DB here. Packets on this VLAN pair with the help of this are checked against. Get this? Get this? So all the signatures for this traffic which is here should be configured where? Under this database, and all the signatures what you want between this should be configured under this database 7. Get this?
Which is the name of this implementation?
Which one?
Oh,
And same.
you have 2 IPS.
No, I have one IPS. I have.
One IPS with you use the different interface.
Yeah, exactly. So basically what you need to understand is, maybe I have this. Wait, I'll show you. Hang on for a minute. Basically what I want you to understand is, I have a single IPS with 4 interfaces. I have a single IPS with 4 sensing interfaces. Okay, but this is how it is deployed. I'm using all the interfaces. Understand this. I'm using all the interfaces. I'm using interface 00, I'm using 01, I'm using 02 here, which is for VLAN pair. It's connecting VLAN 50 with VLAN 60. Here I'm using 00 and 01, which are in interface pair, wherein any traffic coming through 00 goes to 01, coming through 01 goes to 00. Fine. So I am using 1, 2, 3 interfaces. Remaining interface is what? Still one more interface is remaining, right? That you can use in promiscuous mode. Get this? It's the same IPS. I'm using same IPS. I'm using the same IPS. Fine. So for DMZ zone, if you want to configure anything, you will be configuring here. Apply changes.
PPM से भी hard लग रहा है.
So how I'm going to do this is this way around. What I'm going to say is we have firewall here. This is DMZ. We have R4 here, right? And this is R2, which is on outside. So R4, basically R4 address is 172.16.30.4. I'm going to translate this IP to some public IP. Okay, let's say 129.1.1. Fine. So from outside, maybe from R3, let's say, if you try to telnet 129.1.1, you should reach where? You should reach R4, right? Now understand that we have deployed IPS here in interface pair mode, isn't it? Wherein the traffic is checked against signature database, where we have already configured one signature called my telnet signature. But this signature is present in 60 database, which basically checks delete keyword, right, in the packet. We are going to configure another signature that would be configured under signature dash db dash 0 under this database. We'll call this as, let's say, tel_sig, and this will match anybody executing erase command. If anybody is executing erase word, then we try to block. This is in a separate database, understand this. Fine. So this signature tel_sig we create where? We create under. So let's first do this one. We'll translate this IP to this IP. So we go to firewall first of all. Go to firewall. ES4. I say static DMZ 2 out 129.129.11 172.16.30.4. Fine. So we have basically translated this, right? So at this moment R4, if R4 tries to telnet to 20 dot, he should find himself with translated IP. This should be 129.129. Let's translate it, right? So fine, you log out, we log out. So translation is functional. Okay, next thing, I go to firewall. I'll open up a port wherein it allows telnet to R4. So from anybody to host 129.129.11 on port number 20. Show running access list. Here is the entry which allows telnet traffic which is going to come from R3 towards R4 DMZ server. Done. Next is on the IPS. I go to IPS. I'll go to all signatures of IPS and signature DB0, the database which is checking the packets on interface VLAN pair, which is between firewall and R4. Good. So here I change. I say add. Let's add a signature here. I say add a signature string TCP. I'll say the signature number is the same thing. Let's say I'll say signature name is tell erase sig. Description, the alert note is, let's say erase command executed. What do? You produce alert. That's what, let's say, that's what. You just produce alert. If the string matches this word, E R A S E. If string matches this, the port is 23, it's a 2 service. Get this? Produce alert if the string is matching erase keyword and the packet should be on port 23. It's a 2 service, means it's coming to the route. Next, finish, apply. Understand, we are doing it under sig db0 here. We are not doing it under sig0, the default one. We are doing it under sig db0, the custom one what we created. Fine. So if you filter it out on type tune and under custom signatures, you see your signature here. So if I go to R4, R3, from R3 try to telnet to 129.129.11, which is a translated IP. Doesn't have route. Okay, so let me try this. You ping DMZ server telnet you reach R4, the server which is inside DMZ, right? The signature is not for delete, the signature is for ERAS. You can execute because you are not blocked, right? The action is to generate just alert, tell erase sig, right? The signature is triggered. What was the signature detail? Erase command execute. The signature does get triggered. Fine. You can select the action. So you are going to 172.16.30.4, the translated IP, the real IP. Fine. You can change the action, configuration, policies, under signature DV0, go to all signatures, filter out the custom signature. Here change the action. As of now it's alert. Change the action, say deny connection. Okay, apply. So it's done. Your action is now this and to deny connection. To test this, you say ERAS E. I can't even type E. I had not even typed E before it. Fine. If you go to IPS, monitoring, events, and check the event, it's a fine. This shows what you typed, what attacker did, and this is what actually got executed. So we go to configuration, sensor management. Host block, network block. He is not blocked. See, he is not there in the block list because he is not blocked. What did we do? We just said deny the packets from it. Fine. Get this? Tomorrow we'll look at some extra configurations. Alright, like how to create custom signatures and how to create
एग्जाम में आता है ना सर?
yeah, we'll look at look about all these things. Okay.
Exam we have to do through GUI only.
Yeah, through CLI as well. We'll look who are allowed, how do you modify the ACLs here through GUI. We'll look how do you set up NTP, the timing. Okay, and we'll see how do you create custom accounts here. Okay, we'll look at some of the things. We'll look at some of the things from here, the logging. Packet logging. Fine.
So can't we use on GNS?
Then we'll look at event action rule. Fine. We'll look at event action rules. Right. We'll look at event action filters. Okay. Your general, like whenever it is getting blocked, the information is available here. It is getting blocked. The attacker is denied for 3600 seconds, which means 1 hour. The block is for, so somewhere it means after 30 minutes you can retry the attack. Fine. So you can change the timings here. Fine. We'll see the threat categories and all those things. Risk category, how do you change them? Okay. target value rating, event action filter. So we'll look at the remaining things, all these things tomorrow. Okay, so you understand, right? How do you create an extra or virtual sensor? How? You click on add virtual sensor and you create. Fine. You understand how you link the interface with virtual sensor and the signature database? How you create custom signature database? You click on signatures and you click on add and you create signature database. Additional. What do you want? Custom signature database. You guys understand how you create custom signatures? Custom signatures I'll teach you tomorrow. I'll demonstrate you tomorrow. But you understand how you, these are default signatures, how you modify them. You understand this? Okay, we'll look at the actions as well. Don't worry, we'll look at different type of actions. Here the actions, what you see, there are some actions which are for future consequences, some action which are just for time being. We'll look at different signatures, which one to be used, okay, which action to be defined. Alright, all this tomorrow. Fine. So tomorrow same time.